everyone. Welcome to my math teaching today again. It has been a while. I was very busy to set up my website course online and organize on the files and lesson plans and a lot of work and very busy. So I'm so happy today to get back to teaching online to all of you. So if you like my video today, please hit subscribe and give me a thumb up to cheer my spirit up. Thank you. So today in this video, I will talk about the differential equation. So first, let's examine what is the differential equation look like. Let's see. In the past, you have learned algebra 2, right? Let's say algebra 1. You have an equation something like 2x plus 5 equals 15. And your purpose is, you want to solve for x. That is, in algebra 1, you already learned that process. So that is a simple equation. Now, when you progress to the algebra 2, you have something like 3x squared minus 12x plus 4 equals 0. And your purpose is, what is your purpose? Your purpose is solve for x as well. Same thing, right? Now we progress to differential equation. So in our differential equation, this x squared, instead of just x squared, just the regular number, like x, if we solve, we get x equals 6 or minus 8 or minus 17, whatever, right? If we solve this equation, that is a sample like that. But in our differential equation, this x squared is no longer, it's just the number value. You will see something like d squared x over dt squared. And what does it mean? This means the second derivative of x respect to time. And this second derivative of x respect to time equation, let's say maybe adding with 5 equals 0, something like that, right? So now our purpose will be solve for what? We have a differential equation, so we're not going to solve for x anymore. We solve for the function f of x. So that is a higher progress level of, hierarchical level of algebra 1, progress to algebra 2, and progress to math 12 calculus level, something like this, right? Now, in this course, you will see some lessons similar to the first year of calculus lesson in the first year of university. Not quite equivalent, but it's similar in maybe half of the course. You will see like there's some lesson familiar to you if you're taking the first course in university level. And that's why I told you, if you're taking my course online, it helps you to have a smooth transition from high school to the university, regardless any major, if you have to take at least one first level course in the university. It's very useful in terms of mathematical experience, right? Because the theory in the theory and the experience in university is quite a little bit different from high school. You learn, so you need something like familiar, so you get used to with the level of higher level of thinking and practicing in university. But anyway, this course will help you to do all of that. Okay, so let me get back to the question again. So differential equation here, you're going to solve for function f of x, right? And let me give you an example, right? Let's say if you have an example of force equal m times a. What does this equation mean? Force is, in physics 11, right? Any force of action, right? And this force equals the mass of an object times with the acceleration of the object, how fast it's moving, right? Force equals mass times acceleration. So, and that's true. Like if you have a bullet, the mass of the bullet is very small. But when it left the gun, it can become a massive explosion and have a huge force. And why is have a huge force? Because the bullet go very fast. The acceleration of bullet is so huge, it's so fast, and that's why this force becomes so powerful, could kill a person, right? So could destroy something. So that is we're talking about the force. Force equal mass times acceleration. Now let's say if I want to solve for acceleration, so I'm going to solve isolation A. I'm going to use algebra one skill to pick the number A to the left and isolate it. So it means this M go down here, A equal force divided by M. That's how you solve in algebra, right? When you equate the equation, you pick the number left or right or whatever. So that is the equation. It's the maneuverability from this equation when we solve for A. So A equal force divided by M. But what is A? That's in my purpose. I want to get into here, right? What is A? A actually is V prime T. We learned that already. And what is V prime T? V prime T the same like d square x over dt square. And this we get into, we call it second ordinary differential equation. And we call it second because this is the second derivative, right? We have first derivative and we have second derivative. So this is the second derivative. So we call it second ordinary differential. Now, if we integrate this derivative, we get back to the first level. We get back to dx over dt. And this first level is first ordinary differential. I'm going to put in the short form equation, right? So, example, let's say given d square x over dt equal 20. So integrate 20 dt will give you what? 20t. And that's equivalent to dx over dt are the same like v of t, velocity, right? Now, if we integrate one more time, 20t, then what do we get? It's the same like antiderivative, right? So we get 10 t squared plus, actually, I forget, this should be 20t plus c, right? So let's call this c1. So that now integrate second time, we have an arbitrary of another constant plus c2. And that, it gives you more information. You can find out what c1 and what c2 and put back into equation, right? We did that in the previous lesson. So I just want to recall some previous concept and connect it to your new formula of differential equation. And today the lesson is, our purpose is to solve our differential equation. the same like antiderivative, but in the equation form. So we have to solve it in the equation form. And after this, I want to connect this lesson to the idea of the law of natural growth in the application of the antiderivative, right? So see, like in my course, I put the idea, the concept, one by one sequence progress, so that it have a connection of the ideas, and you see how the mathematical concept roll in a hierarchical way and have a meaning. If we put them together in the logical order, right? So let me show you one question of how to solve, not one, maybe one or two, three questions today, how to solve the differential equation. So after you get the idea of what differential equation mean, it means this, and it means this. Purpose is solved for f of x. So now let's get into find out solving equation, solving differential. So after you have some ideas about what is the differential equation, we are going to get into the question and the answer of how we're going to solve the differential equation. So I'm going to make this video is long enough as 1 hour for you to see how boring it is. Okay, I'm just kidding. So let me give you the first question and I will show you how to solve that. So let's have a look at number 1 question. So we have the equation dy over dx equal minus 4y. How are we going to solve this? And given the information is y of 2 equals 6. Okay, so let's see how I'm going to solve it. Now, to solve this equation, I'm going to, step 1, right, is separate x and y. So we're going to separate them. So we're going to bring y to the left-hand side and we bring x to the right-hand side. We separate the variables. So I'm going to say dy divided by 4y. Now multiply, kick to the other side, become divide, right? We reverse the operation if we bring to the other side different from the original equation. So we want to bring this to the left. We have to reverse the operation. Multiply become divide, divide become divide become multiply. So we'll say dy divided by 4y, and I'm going to keep the minus here, minus 1 right here on the right hand side. I'm going to bring the dx to the right hand side, divide become multiply. So now we'll separate again. We'll say 1 over 4 times 1 over y dy equal minus 1 dx. Now, at this point, I'm going to integrate both sides. I'm going to integrate both sides. So when I integrate, I allow to bring the constant to the front. In front, right? So I integrate like this. As well as this negative, I'm going to integrate like that. I bring the negative outside. So now, antiderivative, 1 over 4 still 1 over 4. Antiderivative of 1 over y is ln y. And I'm going to put in the absolute value because to make sure that we don't know what y equal. we want to make sure this number inside have to be positive, right? We cannot take the ln of negative number. So that's why we put the absolute value equal. Integration of this will be minus x plus c. So now, because I have 1 over 4 ln y, so I'm going to multiply both sides by minus 4. So if I multiply both sides by minus 4, like the same, I get rid of this number, right? Or kick this number to the right-hand side. So multiply both sides by 4, I will have ln y equal minus 4x plus 4c. So integration of that is minus x plus c, so minus x plus 4c. Okay, so at this point, now let me change this a little bit. We got to be careful because this is like outside the bracket, right? So the whole thing here should be like this. And this will become minus 4x minus 4c. Okay. So now we'll raise both sides with the base e. So we're going to have e to the ln y equal e to minus 4x minus 4c, and e to the ln y equal y. That's how logarithmic evaluation is, right? E to ln y equal y equal e to minus 4x times with e minus 4c, right? When we multiply the base with the same base, the number with the same base, we add the power, right? So that's how I split them like this. Now this become a constant number. E to minus 4c, it just stands for the constant number. So I'm going to change this become c. So now I have the equation y. I'm going to bring the c in front, right? Change this become c and I bring in front. So e minus 4x. Now at this point, what do we do? At this point, we already achieve our original function, right? So f of x equal y equal this. This is our equation, original equation. Now, because they give us y2 equal x equal 6, so we can substitute y equal 6. So now we're going to solve for c, okay? Now solve for c. So 6 equals c, e to minus 4x, we substitute by 2. So 6 equals c times e to minus 8. Now at this point, I'm going to kick the e to minus 8 over the other side, so multiply become divide. And that gone. So now I'm going to bring this up. So 6 times with e to the positive 8 equals c. So now I know what my c equals. Substitute back into this function. You know what? Let me go to the next bar. So simplify this. I have y equal, and you see it, right? Y equals c, but we know c, right? C is 6 e to the power a times with e to minus 4x, right? We follow this and we substitute c to here. So now we can rearrange it again. It will be 6 e to minus 4x plus 8. So that's how we done. We solve This is the final answer. Final answer. Okay, so I just showed you how to solve the differential equation. That is just the question 1. Now, I'm going to make this video long enough for you to feel so boring. I'm just kidding, right? But actually, math is sometimes really boring, I found. But anyway, hopefully you still enjoy my video. So I'm going to go to the second question. So we're going to solve the second question. And probably I have to erase the bar again. So we have the equation dy over dx plus e to the x plus y equals 0. So that's the second question. Now in the second question, we don't have to, we're not giving the data information, so we just try to find f of x, the original function from here, right? So in this question, we don't have to substitute like this and so on because we're not given the information, okay? So now, how we do this? Again, I'm gonna bring this to the other side of the equation. So I will have dy equal dy over dx equal minus ex plus y. And I'm going to kick the dx up to here. So I have dy, let's leave it for now. Dy over dx equals, I'm going to separate, right? Separate this equation, become e minus e to the x times with e to the y. Now, why do I do like this? Because I want to bring all the y together with the y and separate the x with the x together, right? So we're going to kick the dx up here. We'll bring the ey down here, okay? So dy divided by e to the y will be equal minus ex multiplied with dx. So now I'm going to bring this up. So e minus y dy will be equal, right? This is positive. When I bring it up, become negative, right? That's negative power, right? So e to minus y, and let me put it up a little bit so that we know. Okay, so minus ex dx. Now at this point, I'm going to integrate both sides, right? So integrate. So what is the integration of e to minus y? The integration of e to minus y, like an antiderivative, is the same, right? That's the formula. So it equals e to the minus y, and actually minus e to minus y. And the integration of this is minus e to the x plus c. At this point, if I want to solve for this y, I have to take ln both sides. So I'm going to put the minus outside and I'm going to put ln of e to minus y equal minus ln e to the x plus c. Put them in the bracket. Now, because they both minus, right? But let's leave it for now, okay? So now I'm going to say minus ln e to minus y equal minus y. Ln e to minus y equal minus y equal ln e to the x plus c. And this will become y, it's minus, right? Positive, right? Negative to negative, positive. And this is our answer. Now, because this question, the second question doesn't give us the data, so we just stop right here. We don't have to solve, substitute, and so, right? So that's how the question 2 has been done. Now, let me show you the third question. See how long we're going to be. we're gonna last with this kind of stuff. Sorry, I have to take my time to erase this. And you know what? If I'm getting tired, it means you get boring. Okay, so let's go to the third question. Now I still have a lot of energy, so let's do it. So we have dy over dx. Still a little bit interesting. Equal 3x squared over 4y. How are we going to solve this equation? And one more. This time, given information, given y1 equal to. Okay. So how we do this? Let me see. In this equation, again, we want to separate y on one side and x together on the other side. So by doing that, we have to do cross multiply. Okay, so 4y dy, right? 4y times dy equal 3x squared times dx, right? Cross multiply. At this point, we're going to integrate both sides. So this will become 4 divided by 2 y squared equal 3 divided by 3 x to the power 3 plus c. So 4 divided by 2 is 2y squared equal x to the power 3 plus c. Okay, so we have 2y squared and we don't want 2y squared. We just want 1y squared. So we divide both sides by 2, right? So we got y squared equal 1/2 x to the power 3 plus c over 2. Let's separate them for now. Okay, so now what do we do next? We solve for y. So we have to take square root both sides, right? So that we can cancel this power with the root. So we take square root both sides, the y will become this happen. So now we have our original function f of x equal y equal this. So we're going to use this data and solve for the equation. So solve for c, right? So if we have y1 equal 2, it means 2 can substitute in here. And the x can substitute by 1 to the power 3 plus c over 2. Now, if we want to solve for this ugly radical, we have to raise both sides by the power 2. Right? So we can get rid of the radical 2 and power 2, both sides. So 2 to the power 2 equal 4, equal 1/2. 1 to the power 3 just 1/2, right? C over 2. So move this number together. 4 minus 1/2 will be equal c over 2. Common denominator, a minus 1 over 2 will be equal c over 2. Now at this point, because both of them have a 2 as a common denominator, whatever we do to the left, the same like we do to the right. I hope you can see the board. We can just cancel the 2 down here. So a minus 1 is 7 equals c. So we have 7 equals c. So now how do we do? The next step, we plug back, right? Plug back. Look back into the original equation. And our original equation y equals square root of 1/2 x to the power 3 plus c, now c is 7. So that's how we answer the third question. So this is the final. So now you see that I show you 3 questions. Each question are different. None of them are the same, right? So, but the idea is we try to solve for the original function and we get the equation, and sometimes we have to solve for c as well. So I'm done with the third question. Now, let me give you the last question. How are we going to deal with the last question? Gotta be interesting, right? I hope so. And you hope so too. Now, I hope that my teaching not so boring. After 13 years tutoring one-on-one and teaching in the classroom as well. So now it's a time for me to show you over the internet. Okay, so let's give you the number 4. Number 4 is say dy over dx equal 3x squared y given y of 2 equal 1. Okay, so how we deal with this? Again, we have to separate y to the left side and x to the right hand side, right? That's the first step we do. Separate variable. So I will say dy divided by y equal 3x squared times dx. That's always the case, right? So because I show you, I explained a little bit on the first and second question. Now I'm going a little bit faster, okay? So dy divided by y equal 3x squared times dx. So at this point, I will bring this up. And when I bring this up, this is y to minus 1, right? Minus 1 dy. You know what? Let's leave it like this for now. So I'm going to say 1 over y dy equal 3x squared dx. Right? So now integrate both sides. So what is the antiderivative 1 over y dy? Antiderivative is will be ln of y. And we put in absolute value again. B equal, integrate this will be 3 divided by 3 x to the power 3 plus c. So ln y will be equal x to the power 3 plus c. Now I'm going to raise both sides by the e base, right? E to the x to the power 3 plus c. So e to ln y equal e to the x to the power 3 times with e to the c. Now I'm going to substitute the y. I hope you follow me, right? You get this up to here. I go a little bit fast, right? So e to x to the power 3 times e to the c. And we substitute this by 1 using this information. Y equal 1 and x equal 2. So x to the power 3 is 2 to the power 3. times with a to the c. Okay, but remember this a to the c is a constant, so I'm going to make it like c, right? Actually, I should do that here, right? So 1 equal c a to the 8. So 1 divided by e to the power a equal, cancel, equal c. So we have this equal c. So now I can bring this up. So e to the minus a equals c. Plug back into the equation. Our equation original is which one? This one. And we change this becomes c, right? So like that. So this becomes y equal c e to the x to the power 3. And remember, we can substitute c by this value. So we have y equal e to the minus a times with e to the x to the power 3, which is the same like e to the x to the power 3 minus a. So that is our final equation. That is the answer with the star here. You see our final answer. So this lesson today, I'm going to summarize a little bit what we do today, right? So at first, in the first part, I show you the meaning of what is a differential equation. So after I show you the meaning of what is a differential equation and how it looks like, I am showing you the next step. I was showing you how to solve the differential equation. And I went through 4 questions today with you, and I hope you follow it. If you register to my course online, you can have a lecture, right? Whatever notes in here, and you can have a practice exercise to practice, follow step by step like what I show you. And I also give you variety of different types of differential equation. So that's how the question we learned today, right? So that's the lesson today. That's our topic today. So I show you how to solve differential equation. Now, as the part of my lesson today in this video, I would like to show you just one question to connect how the differential equation derive and gave us the formula to be able to solve any problem in calculus, follow the laws of natural growth easily. So let's take a look at the question. I will read it out loud to you. And this is the last question, I promise. The laws of natural growth, the population of bacteria grown in a culture follows the law of natural growth with a growth rate of 15% per hour. If there are 10,000 bacteria presented initially, how much will there be after 4 hours? So let me denote that any growth rate follow the proportionate of its body, right? So we will have, by common sense, we know that we have dp, p represent for population, over dt equal kp. So let k is the rate of growth. Of course, the population p will multiply with k when we take derivative of dp over dt respect to time, right? dp respect to dt, derivative population respect to time equal kp. Now, yesterday, yeah, last week we learned about the antiderivative, and this week we learned about the differential equation. This is the differential equation. So we are solving this differential equation right now to apply to this word problem. So again, like we're going to bring the p with the p together, same like we bring the y together and the x on the other side, right? So now we bring the t to the other side and p to the other side. So we have dp over p will be equal k dt. Now I am going to rewrite it in terms of 1 over p dp equal k dt. So now if we integrate both sides, what do we get? Ln, we get ln p absolute value equal k t. So now, and actually it should be kt plus c. So now continue, I will raise both of them by base e ln p will be equal e kt plus c. So it's the same like, so e ln p equal p, right? So the population equal ekt equals c. I can separate it like this, kt times with ec, and we know that we can replace this constant by c, right? So our formula will be p c e k t. So we start by the common sense, right? And we do differentiate, solving differential equation for the original function. Keep in mind that this is over the time, right? The rate we'll have to multiply with is proportionate of body. And then if we want to get back to initial function, the function here is the population function, the role of population function in terms of time, right? So instead y in terms of x, this is like the population role in terms of t, in terms of time. So we solve for initial equation, and this is what we get. And this is how we apply the differential equation. So now we come up with this formula, right? Then now we will use this formula and solve this easily. So we know that 15% equals 0.15, and this rate is the rate of growth, which is equal k. So our population, if we want to know how much it is, now actually we should solve for the c here, right? So let's solve for the c here as well. So we know that initial we have 10,000 bacteria. So we replace p here by 10,000. We say c, we want to solve for c. Now ekt is at time equals 0. At time is 0, t represents 0. If we put here k times 0, so ek0 is just 1. So this is equal 1. So c equal 10,000. So our formula in this specific case will be 10,000 for c, right? E, k, t. So now if we want to solve for how much the bacteria will be after 4 hours, then we just follow this equation. P equal 10,000 at start. E is just E. K is 0.15. Time with T, T is 4 hours. So we do this. If we use our calculator, let's figure out how much it will be. So we have E to the power 0.15 times 4, enter. So the rate of growth is this much. Now we're going to time this with 10,000. So we get 18,221. So the answer will be 18,221 bacteria. So after 4 hours, we have the number of bacteria is 18,221 bacteria. So I just want to show you one question application related to the law of natural growth, which is we use a common sense knowledge of proportionate growth, right? So dP is the derivative of the population over the time. So the rate of change of this population equal the population time with the rate of growth, K times P. But keep in mind that this is the derivative equation, right? This is derivative equation. It's not the initial, it's not the function of the popular. So to derive the function of popular, we have to solve for this derivative equation. And we call it differential equation. So follow the step I just showed you in before. So we separate the P to the P and the T to the other side, right? Instead of Y and X, now we use P and T, but the idea is exactly the same. So we solve the differential equation to come up with the function. And actually, this should be P in terms of T, right? We can write it like that as well. So this function which help us to follow this formula and find out how many bacteria will grow, follow the laws of natural growth. So this is one of the application, but there's many more to come up with the logistic equation. Any application in the this unit apply to the differential equation, I will show you and to solve a lot of word problems. So in my math teaching, I tend to focus into first of all, the computation. You have to know how to solve the equation. You have to know how to do derivative and integration. That is the computation part. But then after that, we have to learn how to read the word problems, how to interpret them, and how to apply to what we learn. So that you see mathematics play the roles in our society in all aspects of our life. And that's my protocols, my purpose when I design my lesson plan and the course curriculum, the course content. So anyway, I hope that you enjoy this long video, and thank you for watching. See you. Stay tuned for the next video. Bye for now. So after we have gone through on the lesson about solving differential equation, apply the differential equation into the word problem about the laws of natural growth. Then in this video, I will talk about the Newton's law of cooling, which is also an application of the solving differential equation apply, and the Newton's law of cooling all be the laws of natural law. So let's see how all of the concept look like. So please bear with me in this video. I have some written question on the board, written notes on the board, and I will have to read it out loud to you because regardless my voice, my accent, whatever, I hope that it doesn't sound so bad to you. But in order to explain the concept, I have to connect the ideas from one to the other. So please forgive my talkative today. I have to read the notes out loud to you. So let's see what it looked like. Newton's law of cooling. It says that the rate at which a hot body cools to the temperature of its surroundings is proportional to the temperature differences between the body and its surroundings. So what does that mean? What does this mean? Let me connect to our real life problem. If you have a hot cup of tea, right? Now, a hot cup of tea is your body temperature. And if, let's say if you just boiling the water and you pour in and you produce a hot cup of tea. Now the temperature, of course, is still very hot, but when you bring it outside to the cool air, so the surrounding temperature is the cool air outside, will cool your body hot cup of tea down a lot quicker than you leave it in the room temperature, in the surrounding temperature. So all of this is just the natural phenomenon and a common sense. And you see that's why I told you calculus is related to all aspects of our life, not just the population growth, but now we're talking about the temperature, and maybe we also apply this law into the solution in chemistry when you pour the salt into the water, and the degree of mixture, like the solution, the solvent, I think, the mixture, right? Everything is about rate of change. So let me come back with this. Now I'm going to record dy over dt equal ky. Now you know this, you are familiar with this differential equation, right? This is the rate of change of the y function respect to time equal proportionate rate rho multiplied with the body, right? Y here is a function, the body. Okay, so we accept it. And remember in previous video, I told you if we integrate both sides, we bring the y to the y, right? We say dy over y equal k dt. And then we integrate both sides, then we continue this process. Now I don't want to go to solve this differential equation already, because I already showed you how to solve it 4 or 5 questions before. So now we're not going to bother. But after we solve, right, remember we come up with the formula y equals c e k t. And this formula we call the laws of natural growth. The law of natural growth. And we accept that. We say, okay, so we solve the differential equation, we integrate both sides, come up with this. So now let's relate it to our temperature problem. Okay, so let's relate it to our temperature. Let's say your y function here is a function of our temperature. And this integration, instead of dy over dt, now we have dt, which is the rate of change of temperature, right? Derivative of T, temperature, respect to time, dt, equal k. Instead of y, our function now is t, right? So that's how we related this equation with this. Now, actually, this is obviously, right? However, we're talking about the surrounding temperature. So we add something detailed, right? So this T is no longer just the T. It's just one value. But this T will become the temperature of the beginning, T0, minus the surrounding temperature. Because it says the temperature is proportional to the temperature differences. So the difference is the original temperature minus with the surrounding temperature. And we denote A is a surrounding temperature. Okay, so I'm going to say this is original temperature, right? Original temperature. And this A is surrounding temperature. So this, we apply this differential equation into here. So now, if we integrate both sides, right? So actually, now remember, this is the rate of change, right? And this is our function, right? Because this y here is stand for this root, right? So our t minus a here, remember this t minus a here, I'm going to put it here, is actually is a function. It's a function of t. It's a function like f of x. But in here, it's like t of t, respect to time, temperature respect to time, right? So this is the variable, okay? Equal, so t minus a here is a temperature, is the function. So instead of derivative of only this, we can say this is like, we have d of t minus a, right? Derivative of this over t dt respect to time equal, so this is this, right? So we just replace this t here is the function, the difference between the original function, the original temperature, minus the surrounding temperature. That's all we did, right? So instead, we rewrite this, okay? We rewrite this. Instead of writing just the t, we're going to write the whole group like this, because this is the difference between the temperature, original and surrounding. But remember, this is the function, right? It's not just the one numerical value. This is the function. It's like the original function f of x, or the same like temperature respect to time, right? This like this. So after obey this law, remember the law of Newton's law of cooling. RB is the law of the natural rule, right? So Newton's laws of cooling, Newton's law of cooling, RB, the law of natural rule. Okay, so the Newton's law of cooling, RB the law of natural rule. So instead of writing like this, we can just rewrite like this function, right? Because after we integrate both sides, right? Remember, we solve the differential equation, and if we treat this as just one group, it's just like a y here function here. We treat this as a y function. We treat this as a y function. Our function original after integrate both sides and solving differential equation will come up with the original function t, temperature respect to time, the same like original function f of x, right? The same like y here, right? So will be equal, C and then E, K, T. So now we have to, so we accept this. We say Newton laws of cooling, obviously this temperature law of natural rule, and that's how it look like, right? But now we have to know what our C is. So let's say at the time T equals 0, T0 equal T, right? At the time T equals 0, T0 equals T. So if we follow that, we will have T minus A, right? Our function, right? This is a whole function, T minus A will be equal, right? Will be equal, our T0 minus A and E, K, T. And that equal like C, E, K, T. Now, at the time T0, then T0 minus A will be equal E to the 0, right? And that equals C, E, T is 0, so substitute 0, this gone, right? And we left with C. So T0 minus A equals C. So now we can substitute the C by T. Our function is T minus A. And remember, this is the home function, right? This is not just the variable. This is like f of original function, right? Okay. T minus A equal the C here, we substitute by T0 minus A, E, K, T. So now, if we solve for T, what happened? We solve for T, we got T0 minus A, negative move to the other side, become positive, plus A. So this is the formula for derived from Newton's law of cooling. And in this Newton law of cooling, I'm going to have to erase some of this here so we can continue. And this Newton law of cooling is RB the laws of natural rule, and we come up with this formula. So this is the formula of Newton law of cooling, right? Formula of Newton laws of cooling. So that's the formula for this. Okay. So now we understand the formula, how it derived from, how it related to differential equation from the original, and we come up with this formula. So now we're going to use this formula to solve our application problem. Okay, so let me read our problem. An example. A rod steel at 900 degrees C is cooled by the air temperature of 20 degrees Celsius. C here is Celsius. So we have two temperature systems. One is Fahrenheit and one is Celsius. Now in the scientific problem system, we use a Celsius, and Fahrenheit is empirical system, right? Which is most of the problem we solve now. We use an international scientific system, which is Celsius. So a rod steel at 900 degrees Celsius is cooled by the air temperature of 20 degrees Celsius. After 1 second, a rod steel is 400 degrees Celsius. When will the steel reach a temperature of 40 degrees Celsius? Okay, so let me denote some of the information in here, right? So that we can solve it more easily. So what it say here, given T0 equal 900 degrees Celsius, right? That's our original temperature of a rod steel, very hot, right? The surrounding air temperature is A, equal 20 degrees Celsius, right? The time is 1 second, so which is, let's say T0 equal 1 second. After 1 second, a rod steel is 400. So the final T1, the final temperature T1 equal 400 Celsius. When will the steel reach a temperature 40? So there is another temperature, final T2 equal 40 degrees Celsius. And the question asks, so this is the given. So the question asks what? How long? So ask for small t, how long for the temperature become 40 degrees Celsius? Okay, so these are the data keep in our mind to do this problem. Now let's follow the formula. So we have T equal T0 minus A adding with, and actually, I'm sorry, I think my mistake, I'm sorry. It should be, I'm missing the whole thing here. Should be EKT adding with A. So that should be the formula. So that's EKT adding with A. Okay. So we have T equal, our T0 is 900 minus air temperature is Celsius degree. On of this, time with EKT plus with original air surrounding is like that, right? So that is our equation. So now, we're gonna solve this. And how do we solve? We're gonna solve for K in this scenario, right? We don't know what the K here. So we're gonna find out the K. So let's do step by step. 900 minus 20 is 880. EKT plus 20. Now we know that the fact that after 1 second, our T1 equals 400. So we're going to substitute this by 400. And we have AT E KT here is just K. Time is 1 second, right? We know after 1 second, the time here is like this. So now we're going to solve this equation for K. So now I'm going to subtract 400 from 20, right? When we move the 20 here, we subtract both sides by 20, right? So this becomes 380 equal 880 EKT. So now I'm going to divide both sides by 880, right? So I'm going to divide both sides, and that gone, right? When we divide both sides. So we have this equation 300 380 divided by 880 equal EKT. Okay. So if we take ln both sides, ln of 3a, we can cancel 0, doesn't matter. AA, right? Equal E. And T, we know T is 1, right? So therefore, this is just like that, right? So now, E to the power K equal that, and we take ln both sides. So ln E to the power K equal K, okay? And K equal this number. And this is just the number. If we use the calculator, we'll figure out, okay? So let's figure out. So ln 38 divided by 88 equal minus 0.80, round off become 84. So that's on my calculator, right? So can you see it, right? Okay, so now we know K. We know this is our K. You see the K value. So let's look back to the equation. We have the equation, and maybe I can put in like this, look like a function more than, right? Our equation is T equal 880 K T, right? But the K now is minus 0.84 T, adding 20, that's our equation, right? Good, so let's do that. So let's figure out what is the temperature, how long, let's figure out how long the raw steel will reach temperature of 40 degrees C. So we can substitute this by 40, right? Equal 880 E minus 0.84 times T plus 20. Subtract both sides by 20. We have 20 equal 880 E to minus 0.84. Time is the same. We don't know, right? We want to get this answer. So divide both sides by 880. You can cancel 0 here. Will be equal E to minus 0.84 T, and take ln both sides, right? We can take ln and we can take ln. So when we take ln both sides, the whole here is the answer, right? Minus 0.84 t e to ln e to this number equal this number, right? Equal ln of 2 divided by 88. So let's find out. Ln of 2 divided by 88 equal minus 3.78. Okay, draw off. That's how I got from my calculator. Equal minus 0.84 t. So to solve for t, what do we get? T will be equal minus 3.78 divided by minus 0.84. So divide by minus 0.84, enter. We get 4.5 seconds. So t equal 4.5 seconds. And that's how we answer this word problem using the Newton's law of cooling. So our answer for this question is after 4.5 seconds, the raw steel will cool down to 40 degrees Celsius. So I hope that you follow with my on-board teaching today and you understand the whole scenario situation we went through. So I explained to you that the Newton's law of cooling follow and obey the laws of Newton's law, and we already use the differential equation and how we solve it so that we can come up with the equation and the formula, right? And we have our formula is to find the original function from the differential equation. We got this formula. And what we figure out is T0 is the temperature at the beginning, A here is the temperature of surrounding. So when we integrate the rate of change of the difference between them, we got the function, original function like this, right? And all what we do is after we derive the formula, we can use it to plug in the number of both sides of equation and figure out using the data of data given, right? So first we have to find the K here. Now, how do we call the K? Let me define. The K here is the material body. Now, what it is if your material body is a steel, then of course it's absorb the temperature is a lot quicker, right? It's transfer heat a lot quicker. But if your K is the material body is a wood, wood, right? Then of course it's also can be heated as well, but it will be a lot longer, take a lot longer to heat the wood than the steel, right? Everybody know that. It's just like phenomenon, natural phenomenon. So K here, it just say our temperature depend on the rate of change of its natural body as well. So the K here is a material body, okay? And we try to figure out what is the K here And in this solution, in this scenario, we figure out the k equal minus 0.84. In another problem, maybe the k will be different, depend on the body of the material, right? So that is just it like that. And in this question, what do I skip? I just skip the process of how integrate both sides so that we derive this. And what I did, I say, because we already went through how to know how to solve the differential equation, using the equation symbol like y equal dy over dt equal ky, right? And we learned that already. We know how to process. Finally, we get the function equal y equal c e the k t. So all of this already proven, right? So I don't bother to repeat the procedure again. We just treat this as the whole at one number, right? At one y function. But except our function now, it's just more complicated. It's the difference between the temperature beginning minus air temperature surrounding. That's all. But if you treat it as the y function here, then the integration process will allow you to come up with this formula. And now it's just related to our formula to the common formula. We say at time t is 0, the whole thing here is 0, so our c equal t0 minus a, and therefore the t instead of a y function is a temperature function equal this, right? Adding with the air temperature surrounding. So that's on a little bit different, but the idea, the concept is derived from the laws of natural law and how to solve the differential equation. So I guess that I have given you a lot of information in this video. So I'm going to end the video right now, and I hope you enjoy my video. Maybe math is boring, but we learned something, and I hope you enjoy it. I believe that there's some people will, or some student will interested in discovering about mathematics. It looks complicated, but the concept of it is really amazing. I think it's amazing. Okay, so thank you for watching, and bye for now.